Okay, we now know that our equation is first order. So, just knowing that actually tells us the integrated rate law. So this is something that I believe is on your reference sheet. You'll have to check, otherwise we have to memorize it. But we know the integrated rate law will be in the form of y equals mx plus b. And because it was first order, our y here was the ln of concentration. And the m is always the negative k, like the negative rate constant. X is time, plus b is the ln of the initial concentration. I'm using a C here for concentration and a little 0. So this chart is actually really helpful because it tells us these are the general forms of that integrated rate law equation. Okay? So I look at my calculator. Oh. Okay. I look at my calculator and I see that the ln of the H2O2 will equal negative 8.349 times 10 to the negative 4th T plus negative 0.0049. Okay, so what I can do now is I can solve different things about it. So it says determine the rate law, determine the integrated rate law, determine the value of the rate constant. So I know that the rate constant is just the slope of the line. 8.349 times 10 to the negative 4th equals k. It's first order, so the units of k will have to be 1 over, we're in seconds. So that's my answer to that one. And then it says calculate the concentration after that many seconds. So I can use this equation and just substitute the ln of H2O2 equals negative 8.34 times 10 to the negative 4th times 4,000 seconds minus 0.0049. Let's collect like terms, and I'm trying to find the concentration. So let me cheat really quickly. Number 31. When you do this, on this side you're going to get negative 3.3 equals the ln of H2O2, and to get out of the ln we just do e to the power. So this will go away and we will get 0.037-ish is the concentration, so moles per liter. Okay, they could also have asked you what was the initial concentration, so you could take this value, and we know that negative 0.0049 equals the ln of the concentration initially. So e to the power will give us the initial concentration. This chart tells us all that important information. The y-intercept is actually the ln of the initial concentration. Okay, if it's second order, it's actually 1 over the initial concentration. Okay, the slope is always k, and this half-life part is going to come in tomorrow. Okay, I hope that helped. Come see me tomorrow with questions.